All right. So, new year, and as usual, Patrick gets this Mac malware of said year list together. So, just wanted to go through some of the samples in here, if not all, depending on how long this takes. So, I think that this is probably one of the best ways to learn macOS malware reverse engineering. It's what I've done in the past, and it really taught me a lot. So, just gonna dive in. Again, thanks to Patrick Wardle for putting this together. We're looking at the malware from 2025. That was quite a lot. The best thing about this blog post, besides how thorough it is that you can grab the samples that are covered really easily. You can also just grab the PDF, which is what I did here, and yeah, go through this. Super helpful. Again, thank you, Patrick, for doing this. We're gonna just dive into the first one here. I've already read all this. The kitty stealer. So this was actually something that was discovered by me and Zolo earlier in 2025. It's not that interesting of a sample. It's pretty simple, and it looks like some kind of testing at the time. So yeah, not that interesting. I just grabbed all the samples that I'm going to try to cover here, and we're going to start again with Pergler, which is called Kitty Stealer. And if we just open that up in Binary Ninja, we'll see that it's an Objective-C sample. There's a lot of symbols that were pretty interesting if you just go back and go into Pergler. Oh, this is a good time to mention. When you download files from Patrick's GitHub, he has like a malware collection. Again, super easy to grab samples from, which a lot of people struggle to actually get samples, so good place for that. There's usually a README, so if you download one of these corresponding files, you can look at the README and then you can see usually there's like a write-up or potential write-ups that are related to that sample. That's always great because sometimes you grab a sample and you're not really sure, if it's been covered. This is great for following along. So this was talked about way back. If we want to look at some of the interesting symbols in Kitty, give you some idea of what it may do, I just ran the nm command, and I'm just looking at symbols here, and we can see looks like some kind of mangling, so probably like C++ stuff. And so we have like get encryption key, alert, send get, send file. So that kind of gives you some idea of what this may be doing. Also, it leverages curl APIs. You can look for that too. And it has Objective-C message send methods here, which we can see really quickly when we open up the file. So have it opened up here. One really cool thing, just to toggle between this, you can use the high level IL, which will show you those Objective-C message send functions, or you can make it prettier and use the sudo Objective-C. So we're not going to spend a lot of time on this. Again, this was someone's project potentially that they uploaded to VirusTotal, and it was just something we looked at and decided to make a report on it. It wasn't that complicated, but let's just dive in. How do we know that this is some kind of testing? We can see this really clearly up front. They're using the localhost URL here, and we can just make some changes really quickly to see what it does and move on to the next sample. But if we start all the way at the top, right, we're in main, usually where this opens up. So we're in the entry of this binary, and we see the first call besides this NSString reference, which has already been set up here by Binary Ninja. So that's cool. We have this call to UID. So if we double click on that, we're going to have to change these variable names because they're not super helpful. But the first thing we have is this NSTask. This is a class that you can use in Objective-C to like spawn another process. So we have this NSTask as being alloc init. So it's just setting up an NSTask. Let me just change that. Very common with legitimate samples and with malware. We're setting the launch path to be the system profiler. So that's going to be a command that's executed. And we're passing that to the method set, or we're passing it to the method set launch path, which is then being passed into this ns task object. Setting the arguments is going to be this ns array. They actually like have the symbol name there, which is pretty cool. This is inside of the Objective-C array object section of the binary. And we can see this is a structure that contains an ns constant array, which was referenced by this symbol. And inside of here, we have the objects member of the structure. We go in here and we can see that it just has one value for this array, and it is this CF string for the SP hardware data type. So just grabbing this, and that's going to be we can just add a little comment here just to make it prettier. Sets up a pipe. So what is this? This is the pipe here. Pipe. And then file handle for reading. So these are just file handles to read from the pipe. So from the return of this command, we're going to read the value of that. And we're going to skip ahead. And we can see we have this encoding read data to end of file. That's going to get that data. So data. And we're going to init with that data into an ns string. So data ns string. And now we're going to scan. We're going to create a scanner to scan through that data. Scanner. And now we're going to scan up to this string. So we're looking for the serial number system return from this command. Okay, so that's going to be here. That's going to return there, and then scan to string this, and then it's going to return that, scan the string, and we're going to get this value that's going to be related to the serial number. And setting this up with white space, new character. Oh my god, so much stuff. We're gonna trim the characters based on this location too, which ends up being this object that we have returned. So this is going to be the actual serial number. And we can see down here, we could have cheated and just kind of gone to the return and then followed this up. But this is going to return the serial number. So we know that that's what the UID function returns. So this is serial number. And that serial number is probably going to be used somewhere. I'm not sure. Oh, it looks like, okay. So this, we're going to just go over this really quickly. There are values that are being passed here on the stack for this variadic function, just string with format, which is going to take, in this case, two different values that are going to replace these format strings. So this is an Objective-C class object, and then this is like the LD, so like a, forgot what that is right now, but like a string, digit, whatever. And we're going to replace that with two values, so we're missing two values that will basically be used to create this URL. So let's look into that really quickly, because after the UID, we have a call to get timestamp. This is just going to return an NS date. So date. And now we're going to get the time interval since 1970. So date UTC. And it's going to just return that timestamp. And that gets returned here. So timestamp. But it doesn't look like it's actually used anywhere. But let's just go over to where this get timestamp is used. And then we have to look at this from a disassembly perspective to see how we actually pass these values to the string, the format string that then is used to create the actual URL. So, okay, UID, we already talked about that. That is going to return that serial number. We're dealing with ARM64, so that return is going to be an X0. We have this Objective-C retain auto release return value. We're not worried about that right now. That's part of ARC. and we're going to then store whatever is in x0, which is the return value, into this location on the stack. So this is going to be serial number. Get timestamp, we already talked about that. It gets a timestamp and it's going to store that here. So this is going to be timestamp. Okay, and then after that we branch to this address, which is here. We're going to load this value. Not sure what 88 is. That's in x1, not showing up here. And we're going to load this with this ns string. So this is that reference to the ns string. So ns string ref x0. And then we're going to load that timestamp into x8, and we're going to load that serial number into x10. Now we're going to move the stack pointer, right? The stack pointer has an address. It's pointing to the stack. So that is that same address, that pointer is moved into x9. So stack pointer address move to x9. Okay. Okay. So continuing that, we now are going to use x9 as the reference to the stack in order to move these two values onto the stack that are then going to get passed to the string with format method. So the way that works is we're referencing x9. Again, this has that same address that SP is pointing to, and we're going to store whatever is in x10 at that location. And we can see that Binary Ninja sees that as the serial number that was at x10. And then we're storing x8, which again is that timestamp. So 8 bytes away. So next to each other, we're dealing with, 64-bit registers. So we're just going to move that next to the serial number. And then when we actually execute this, we're going to replace the first one with that first location, which is the serial number, and then that timestamp, which is that digit we talked about before, the integer that is going to replace this there. So that's how that's going to work. Again, we're not going to spend too much time on this. It does a bunch of stuff with Chrome specifically and Exodus, and we can see that pretty easily here with the rest of the strings. Last thing I'll go through is this. We can see the second argument, please enter password, is passed into the alert function, and the alert function is going to create an NS alert, which is going to prompt the user. So that this one is that please enter your password. So password prompt, and that's stored here. Password prompt. And we're creating that NS alert, and we're using that to create that informative text for the password prompt. And yeah, so that's going to just prompt the user to enter the password. Okay, so that's the Digitstealer. Again, nothing too crazy. May have been used for some testing, and we can kind of see that because of the URL is pointing to localhost. So now let's move on to the next one. Okay, so going down. Again, you can use this and follow along. These are really well written. Digitstealer. This is one I didn't really spend a lot of time on. I know that this was written about by Tice recently. Don't remember. I think this was pretty recent. JXA based stealer, and it's pretty in depth, and it's covered in this blog post here by Jamf, and we're not going to dive too deep into it because again, there's a lot to it, but we can kind of explore. It's a lot of scripts, and let's just go back out and go into Digitstealer. I think there was a new one that just popped up recently too. Okay, so we have a lot of files here that we can kind of look at. We're just going to browse a little bit. Again, you can look at that README, and we have the blog post here if you wanted to spend more time digging into the sample and using that as a reference material. But we have this SC PT, so OSA script as the first stage. We can just view that really quickly, see what it looks like. Looks like this is going to be the domain, the C2 related to all this. And we'll just kind of walk through this a little bit. For anyone that's not super familiar with OSA script, it's used pretty heavily by Steelers. It's gotten pretty annoying. Some of these scripts are gigantic, and I wouldn't be surprised if this is another one of those that are huge. So you can essentially create new process execution using the shell script related command here in OSA script, and you'll see that a lot. And it looks like we are going to display a dialog, so it's going to prompt the user for their password here, and we're going to check the password with this, which is used by basically every Steeler. It grabs that username and password, and it's, you can see it right here, and it runs this command against it to see if it's like legit. Pretty interesting. Looks like there's some curl that's going to basically replace these different values. Oh, they passed the password in the username and the URL. Okay. Yeah, bunch of stuff. Prompt wrong. That's funny. I guess if it ends up not working, they do something else. They probably just prompt them again. This is related to TCC permissions. Pretty interesting. Okay, so they're getting things ready for what they're going to collect. And yeah, ends up doing a bunch of stuff. Upload and grabbing files. They zip everything up before they send it. And yeah, so stage one, preparing a bunch of stuff. And I guess we have this second stage. Oh, thank goodness they have it deobfuscated here, because I did not want to spend a lot of time with some JS stuff. Okay. Oh, cool. It looks like they're using Objective-C. Oh, yeah, this is JXA. Okay. So same domain here. A bunch of paths are being created that are going to be used as targets to gather the information. So you can see everything that they're going to kind of gather here. So yeah, all of the related Chromium type browsers and their specific locations for data that they're going to extract. We've seen this a lot in a lot of the Steelers, like Patrick says in his blog post here for the 2025 malware. Once you've seen one, you kind of have an idea of what they're going to do. This one's just a little bit, or I would say probably much more annoying to analyze, because of no one wants to look at JavaScript. I know I don't. Yeah, so we can kind of just breeze through this. Extension names. Okay. And we have different values for each one of those, and grabbing all that. And then we have the extensions, all the Chromium stuff. Okay, UIDs, parsing profile data for like Chrome and Firefox, makes sense. Telegram stuff. Okay. And we have the keychains down here, and extracting all this fun stuff. And then looks like it's a big curl command here pointing to that same C2. But yeah, so a lot of script stuff. We've been seeing a lot more scripts used, I think, recently for macOS malware. Not sure what this is for. Looks like some kind of deobfuscation thing that they're going to use here. Yeah, we're not going to spend time on this. I don't want to look at this anymore. Yeah, it looks like it grabs this huge thing and it iterates between that, and we're not going to spend time on that. But again, if you want to play around with some JavaScript, which I don't, you can just grab this file and take a look at it. I believe there was a mention inside of here of the, yeah, right here. So the persistence. So we should be able to see that launch agent installer. Make sure that that's like a, yeah. So let's look at that. Yeah, so it's just going to set up a quick launch agent for persistence. I've seen this somewhere before. Oh yeah, so this is they're going to pipe this out to JavaScript, the interpreter using the OSA script command, and you just specify the language. Cool. And that's going to set up a persistence. I believe this is in the launch agents directory. Yeah. Okay. There's a lot more to this. You can spend time and kind of go through all this. It's actually pretty in depth. I'm not giving it enough time, I feel. I just don't want to look at a bunch of scripts right now. So thankfully, there's this nice diagram that kind of talks about everything and how it works. Awesome. Okay, let's see what's next here. Oh, wow, there's a good amount of stuff. But again, a lot of these are things we've seen in other stealers. And it's becoming pretty common that they share a lot of functionality. Okay, let's continue. Some great stuff in here. Okay, so, Phexia. I think I'm saying that right. This one was pretty cool. One of the main reasons that I really liked this one is because it used a type of technique that I haven't really seen a lot of, which is this dead drop resolver technique. And so this was shared by Malware Hunter team. And when they brought up this dead drop resolver thing, I had to look it up. I had no idea what this was at the time. But it ended up being a really cool sample to look through. So let's talk about that really quickly. I have it opened up here, apps.bin. And let's go to the main. So no obfuscation, which just makes it a lot easier. Makes it not that much fun to go through these, but that's fine. So we are going to, so we can see the persistence is being set up here all the way at the top. First thing that happens, we can kind of go back. We're forking. That's just going to annoy fork return. I'm going to annoy someone that's trying to debug this, but you can get past that pretty simply. It's going to then do a kill all terminal. So it's going to actually kill the terminal, which is pretty annoying. So this is going to be the kill all term command, and then they're going to execute that. So if you're analyzing this, it's going to kill your terminal session. You have to bypass that too. Pretty annoying. So library launch agents, we're going to replace that with the home directory of the user to replace this format string so that we can get the actual path to the launch agents directory. So this is path to launch agents. And then we're going to create that. So we can see this is like the creating that file. It's not a file that's on system when you first like install macOS. So if there's no files that have actually like set up persistence here legitimately or illegitimately, it's going to create that. And then this is going to be the name of the plist file. We're going to use what we already put together here, and we're going to pass the path to launch agents here and then set up that plist file. We're going to open that plist file. So plist open. And now we're going to do an fprintf, and we're going to basically write this gigantic thing into it. So let's make this a little bit better. I'm gonna drag this over a little bit, make sure it can be seen. And then we can just press A here and we can see the whole thing. So yeah, it sets up this OSA script for this file, whatever this executable is in this location. This user is going to be the username, and then it's going to have library inside of there. It's going to have whatever this file is that's going to be executed. And this is the same name as the plist file. It looks like some gibberish. I'm not sure how that was created. But let's go back. That's going to set that up. It's going to set up the persistence. We're going to write this out, and boom, it's going to set that up. Now we get pretty interesting because now we're going to have the actual executable that's going to be executed by this. And we can see that it's going to write to this file this gigantic thing. Now this is where the DDR, yeah, I got that right, comes into play. So here we just press A to make that prettier. And what that means is, so the way that the C2 is captured, it's actually pretty cool. It uses a curl command for two different accounts. So we have, for the first account is for Telegram. So we have that curl out to that link for Telegram, and then it's going to grab that URL that is being used at this account. It's like the display name or something on Telegram. And that allows the malware authors to change this without changing the binary. So they can just go to this account and change that, and then that makes it so that infrastructure, is not so easily taken down, I guess, because again, you don't have to recompile another sample with a different C2. So there's two checks. So there's this one, and then there's another one. So there's some redundancy built in too, and this is for Steam, and this ends up being the actual persona name. So if you go to Steam and you look this account up, you'll see like their name, and then that name ends up being the C2. And this has already changed a couple times, and I've reported it a couple times, both of these, and I believe it's still up last time I checked. But yeah, so they set that up, and then that ends up being another OSA script that is going to then be executed by appending the get.php to that active domain, depending on which one it grabbed. And then it's going to just pipe that to OSA script, another OSA script. It's kind of annoying to see this so much, but that's kind of where we're at. And yeah, so it's going to reach out to one of these two, grab the one that it needs, and it's going to then run this OSA script. Okay, so let's see where we're at right now, because I've been here a bit. So yeah, talked about all this. And okay, so just to talk really quickly about the actual OSA script that is brought down from the C2, there's this really interesting list of commands here that lead to like a backdoor, which is pretty cool. So listen commands, right? So it's going to execute this get task, and this get task is going to reference that C2, and it's basically going to receive a task, and then that task gets executed. So it creates like basically like a backdoor, and you can see that here, do shell script, passing that to sh-c, and piping that to dev null or whatever. So it allows for some kind of backdoor execution of commands from the C2, leveraging this OSA script. That's two of the things that have been pretty interesting about this one. So the DDR and then this backdoor functionality. But okay, so let's see what's next, and I'm probably going to stop here and continue with Paradox on the second one of these videos. Getting close to 30 minutes here. Don't want to spend forever on this first video. But yeah, so again, shout out to Patrick Wardle. This will be part one of some interesting malware from 2025. Again, grab this and play around with it. Grab the samples and just start reverse engineering some Mac malware. All right, well, see you on the next one.